finds one, down on Earth, word spreads quickly. Every few days, the satellite spots a violent eruption in deep space, sending dozens of stargazers scrambling. Whether they're seasoned pros or high school amateurs, their goal is the same.
Go to camera focus mode, then we're going to need to move the dome. Casey?
To catch a glimpse of a star in its final death throes. Going supernova. And leaving in its wake the strangest phenomenon in the cosmos. Patrolling space like a sentry, the satellite telescope SWIFT is on constant lookout for cosmic disasters. And when it finds one, down on Earth, word spreads quickly. Every few days, the satellite spots a violent eruption in deep space, sending dozens of stargazers scrambling. Whether they're seasoned pros or high school amateurs, their goal is the same.
Go to camera focus
Patrolling
mode,
space
then we're
like a
gonna need to move the
sentry,
dome. Casey?
to catch a glimpse
Seasoned
of a star
pros
in its final death
or high school amateurs, their goal is the same.
going
Go to
supernova.
camera focus
Patrolling
mode,
space
then we're
like a
gonna need to
sentry,
move the dome. Casey?
To catch a glimpse
seasoned
of a star
pros in its
leaving in its
final
wake
death or high school
the strangest
amateurs,
phenomenon
their
in the
goal is the
cosmos.
same.
A black hole.
Nothing survives encounters with black holes. The black hole wins. It wins every time.
When something falls into a black hole, it's essentially gone from our universe.
They rip stuff apart and eat them. And then they burp and they're ready for the next course.
And now, evidence of something even more ominous. A new kind of black hole, of unfathomable size and power.
That's a big galaxy, and right down at the center, we think there's probably a black hole that's got a mass that approaches 1 billion suns.
Today, scientists are finding black holes are bigger, stronger, and more destructive than they ever imagined.
It creates energy fields that would fry any life in its vicinity.
Not only do they consume everything that comes near,
You stick your finger down in there, you ain't getting it back.
but their power may reach across galaxies and beyond.
Did the universe really have to be made with these things in it?
We'd like to think they're far, far away. But what if, in our own cosmic backyard, there lurks the monster of the Milky Way? Right now on Nova.
This is just enormous.
As he pores over a set of X-rays, Brian McNamara struggles to diagnose a complicated ailment.
So that's pretty strange.
But his patient isn't a person or any earthly creature. It's a cluster of galaxies, 2.5 billion light years away, with a giant blast of energy spewing from the center. This is the most powerful explosion in the universe since the Big Bang.
To put this on sort of an Earth scale, it's equivalent to about 1 trillion atomic explosions. So it's an enormous amount of energy.
What could produce such awesome power? Whatever it is, it seems to live at the very core of galaxies. And many believe our own galaxy, the Milky Way, is not immune, harboring a powerful secret at its heart. What could lie at the center of the Milky Way? One of the pioneering explorers of our galaxy is Eric Becklin. He's been trying to unlock the mysteries of the galactic center for more than 40 years. But first, he had to find it.
Back then, people weren't even sure where the center was. There was some vague understanding. There was a radio source called Sagittarius A, a very strong radio source, but there was even debate whether that was really the center or not.
Examining other distant galaxies, astronomers knew that the center is usually the brightest spot, tightly packed with stars. But when they tried to pinpoint the center of our own galaxy, the Milky Way, they ran into a problem. The central stars were shrouded by cosmic dust.
There is so much dust between us and the galactic center, it is completely opaque. You do not see the stars in the galactic center. The most powerful telescopes cannot see it.
But there are other kinds of light that can pass through, like infrared, a form of light and heat invisible to the naked eye that travels in slightly longer waves.
Infrared radiation gets through the dust because its wavelengths are longer and the dust just kind of rides on the infrared wave.
In the 1960s, Becklin belonged to a Caltech team that bought an infrared detector from a military contractor and attached it to the end of a telescope.
It was in August of 1966. I was up at Mount Wilson. It was a beautiful night on a small 24-inch telescope. And as we were looking with the infrared detector, we were seeing more and more stars.
A simple chart recorded the infrared light of stars. Stars that until then had remained hidden behind a veil of dust and debris.
This is a signal in the infrared, and each star gives you more signal. And we were building up, as we were getting closer to the center, more and more stars. We were actually seeing through the dust for the first time, and then came to a peak, and then back down again. And I knew immediately that that was the center of our Milky Way, and that I was the first person to actually see the star in the core of our galaxy.
Located the heart of the Milky Way. From our perspective, an inconspicuous speck near the constellation Sagittarius. Is a giant spiraling disk of hundreds of billions of stars, 100,000 light years from end to end. Our sun, about halfway out from the center, sits in the peaceful suburbs. But at the galaxy's core, the neighborhood gets more exciting and dangerous.
There's a lot of gas. There's a lot of dust. This is absolutely the most crowded place in our galaxy.
From Earth, we can see a few thousand stars with the naked eye. If you went to the galactic center, there would be millions of stars filling the sky.
It's the big time. It's where the show really goes on in the galaxy. And so if you go there, you're very much aware of being a tiny little mouse in Times Square, and somebody's liable to step on you.
For years, scientists suspected that a powerful force dominated this galactic Times Square. It had to come from an unimaginably massive object. Some thought it had to be a black hole. An object so strange, it's hard to describe.
What's a black hole? It's a region of space.
It's a point of infinite density. We don't know how to wrap our brains around that. If you fall in, you never come out.
It's not the point of no return, it's the sphere of no return.
Now you throw in a hungry beast in the middle of it all.
It's this monstrous, mysterious thing.
And if you can imagine taking a bowling ball
But, I don't know, eats everything. That's not true.
You have something, you drop it off the top of a building, you're falling in to the deepest well you can possibly imagine. physicists have just as hard a time as anybody else understanding this sort of thing.
It's a black hole. There's no other phrase we can possibly use to describe it.
The current idea of this bizarre creature comes from a radical view of space, time, and gravity. Welcome to the universe according to Albert Einstein.
Albert Einstein had this crazy idea that space and time were curved, and it was the curvature of space that gave the appearance of gravity.
We tend to think of space as rigid and stable, but Einstein proposed that space and time are woven together in a flexible fabric. Massive objects like the sun actually bend and warp the fabric of space-time, creating troughs that smaller objects can fall into.
What actually happens is matter warps space-time. So the very space, the three-dimensional space that we walk through, warps slightly. Warps in on me ever so slightly, but because we're not very massive, it's so minuscule that we don't sense it.
If an object is massive enough, like the Earth, it will warp space-time so we can sense it and fall towards it. That's gravity. But what happens if an object is much, much more massive than the Earth or the Sun? In theory, it could warp the fabric so much it would create an actual hole in space-time. Once something fell in,
Patrolling
it
space
couldn't
like a
escape.
sentry, the
Not even
satellite
light
telescope
itself.
Swift is on constant lookout for
So
cosmic
imagine a
disasters.
place where the gravity is so strong,
And when
turning
it
on a
finds
flashlight. The light would go up and it would never
Down on Earth,
leave.
word spreads
It would
quickly.
curve and come back down just the way a tossed
Every
ball
few
on
days,
Earth.
the
It's
satellite
not traveling
spots a
fast enough.
violent
It
eruption
goes
in
up,
deep
curves, and
space.
comes back down.
Space itself is falling
Sending
inside
dozens of
the black hole.
stargazers scrambling.
It's rather like a river falling over a waterfall.
Whether they're seasoned pros
It's like that, except it's
or high
space
school
itself
amateurs,
is
their
falling
goal
over
is the
the
same.
cliff.
Go to camera.
There's a
focus
place
mode,
where the
and we're
space
gonna need to
starts
move the
moving
dome.
faster
Casey?
than light.
to catch a glimpse of a star in
So
its
the
final
light,
depth.
which is trying to get up, it's rather like a kayak
Going
trying to
supernova.
make their way upstream on a river that's going too fast. They get dragged down to the center of the
and
black
leaving
hole.
in its wake the strangest phenomenon in the cosmos.
Gravity becomes a riptide. The closer you get,
A black
the stronger the current. Eventually, you reach the event horizon,
The
the point of no return.
It wins every
Deep
time.
inside, whatever goes
When
in
something
is
falls
lost
into a
in a
black
point of
hole,
infinite
it's
density.
essentially gone from our universe.
The matter
They
goes
rip stuff
inside
apart
the surface of the black
and
hole,
eat them.
shrinks down
And then they
to the
burp
very
and they're ready
center
for the next
where it gets destroyed in a region of
And now,
infinite warp
evidence
space
of
and time,
something
and it's gone.
even more ominous,
And so, it
new
seems,
kind of
are the
black
laws
hole.
of physics.
of unfathomable size and power.
At the center of a
That's
black
a big
hole,
galaxy, and right
all
down at the center,
equations break down.
there's probably a black hole
Even for
that's got a
physicists,
mass
what
that
happens
approaches
deep
a billion
inside a black
suns.
hole is a
Today,
mystery.
scientists are finding black holes are
We're
bigger,
in want of a new idea
stronger,
about how to explain what matter
and more
does at the center of a
destructive than
black
they
hole.
ever imagined.
We're in need of a new law of physics. It creates
Einstein himself concluded black holes were too strange to be
Not
real.
only do they consume everything that comes
Albert
near,
never really liked the idea
stick
of
your
black
finger down in
holes.
there. You ain't
He
getting
thought
it
they were
back.
anathema. This was
their
something that
power
nature
may
should
reach
avoid.
across galaxies and
The
beyond.
places where
Does
space
universe
and
really
time
have to be
became
made with these things
infinitely
in it?
twisted up.
We'd
He
like to
thought,
think they're far,
no,
far away.
nature shouldn't
What if,
allow that.
in our own cosmic backyard, there lurks
Black holes are certainly
the
odd
monster
beasts
of the
in
Milky
the
Way.
universe.
Right
They were thought to be peculiar, so peculiar as to perhaps not even really exist in the real world. Simply because your equations show that they can exist doesn't require that the real universe has them.
As he pores
But over
a
the
set of
years,
X-rays,
suspicions rose.
Brian McNamara struggles
Stars
to
were found
diagnose a
behaving
complicated
strangely,
ailment.
orbiting invisible objects,
So that's pretty strange.
moving faster
But his
than
patient
expected.
isn't a person or any earthly creature.
Even though a black hole emits no light,
It's
is
a cluster
completely
of
invisible.
galaxies, 2.5
we know
billion light years
exactly
away.
what effect a black hole is going to have on its environment,
giant
on the
blast of
stars
energy
in its vicinity,
spewing from
on
the
the
center.
gas that wanders a little too close.
This is the
So,
most
will
powerful
we ever see a black
explosion
hole?
in the universe since
No.
the Big Bang.
But that's not what's
Put
important
this
here.
on
What's important here
sort of an
is
Earth scale.
we can see
it's equivalent to about
its
a trillion
paw print.
atomic explosions. So it's an enormous amount of energy.
Suspicious that an enormous black hole was
could
dominating the
produce such
center of the
awesome
Milky Way, Eric Becklin was eager to find its
Whatever
paw
it
print.
is, it seems to live at the very core
But even with
of galaxies.
infrared technology, when Becklin
many
pointed the
believe
most
our own
powerful
galaxy,
telescopes
the
on
Milky
Earth
Way,
at his target,
is not immune,
all he saw was this,
harboring a powerful secret at its
just a
heart.
blur.
The biggest obstacle that we had was the turbulence in our own Earth's
could
atmosphere
lie at the
was
center of
blurring
the
the
Milky Way?
images.
Even when the sky is
One
clear,
of the pioneering explorers of our
the
galaxy
gases
is
in Earth's
Eric Becklin.
atmosphere are always on the move,
He's been
distorting
trying to
distant
unlock the
objects.
mysteries of the galactic center for more than 40 years.
To bring his view of the galactic center into focus,
But first,
Becklin would need help.
he had to find it.
So he appealed
Back
to Andrea
then,
Ghez,
People weren't
an
even
expert
sure
in dealing with
where
the
the center
atmospheric
was.
blur.
There was some vague understanding.
The
There was
problems
a
of the Earth's
radio
atmosphere
source
is very
called
much like the
Sagittarius
problem of
A,
looking for a
very
penny at the
strong
bottom of
radio
a
source,
river
but
that's
there was even
moving where the
debate
water's
whether that
moving
was
by
really
very
the center or
quickly.
not.
That motion of the water distorts your image of the penny.
Examining other
Just
distant
like the motion of the
galaxies,
air in our
astronomers knew that
atmosphere
the center
distorts
is
our
usually the
images of
brightest spot,
astronomical objects.
tightly packed with stars.
Ghez agreed to take on the quest,
But when they
to search
tried
for
to
signs of a
pinpoint the
black
center of
hole
our own
at the center
galaxy,
of the Milky Way.
they ran
A
into
decade
problem.
ago, you couldn't look at the center of our galaxy with
central
high
stars
resolution, so
were
you couldn't
shrouded
distinguish
by
stars
cosmic
from one
dust.
another.
Ghez was
There
able
is
to
so
correct the
much
blurring
dust
effects of the
between
atmosphere
us and the galactic center.
with a
It is
revolutionary new
completely
technology
opaque.
called
You do not
adaptive
see
optics.
the stars in the galactic
So this
center.
little animation
The most
shows you
powerful
the
telescopes
benefit
cannot
of
see it.
adaptive optics. You see the stars
there are
without
other kinds
adaptive
of light
optics,
that
you
can
turn the
pass
adaptive
through.
optics on, and all of a sudden you
Like
see
infrared.
stars. And in particular, you see stars
form
near
of
the
light
center of the
and heat
galaxy.
invisible to the
Without
naked
adaptive
eye
optics, you would
that
only see
travels
one
in
big
slightly
blob.
longer waves.
And those stars are in fact the most
Infrared
important
radiation
for us
gets
to
through
track.
the
We track
dust
all of them, but
because
these are the
its
ones that are
wavelengths
the
are
key to the
longer,
problem.
and the dust just kind of rides
Thanks to the new
on the
technology,
infrared wave.
the team could peer into the heart
In
of
the
the Milky Way
1960s,
with
Becklin
amazing
belonged
precision.
to a Caltech team that bought an
Our
infrared
view to the center
detector
of the
from a
galaxy
military
is
contractor.
absolutely superb,
and
and our
attached it to
ability
the
to
end of a
position
telescope.
stars at the center of the galaxy
It was
is like
in
somebody
August of
in Los
1966.
Angeles seeing
I was
somebody
up at
in New
Mount Wilson. It
York
was a beautiful
be able to
night
move their
on a
finger
small
like this.
24-inch
Just
telescope.
2 centimeters. That's the
And
precision
as we
with
were
which
looking,
we can
with
measure
the infrared
something that
detector,
is
we were seeing
26,000 light
more and
years
more
away
stars.
from us.
Once the view was clear,
A simple
Ghez
chart
could start
recorded
the
the
hunt.
infrared light of stars.
If there were a black hole at the
Stars that
center of the
until then
galaxy,
had remained
its paw
hidden
print would
behind
be
a veil
found
of
in the
dust
rapid
and
orbits
debris.
of nearby stars.
Our fingers crossed.
This is a signal
The
in the
conclusive
infrared,
experiment
and each star
to be done
gives
that
you more
really
signal.
demonstrated
And
that
we
there
were
was a
building
black
up
hole
as
to
we were getting
follow
closer to
the
center,
orbits
more
of
and more
individual stars in the galactic
We
center
were actually
very,
seeing
very
through the
accurately
dust
and
for
with
the
the
first
highest
time.
precision possible.
And then came to a peak,
When an object like a star approaches another, more massive
and then
object,
back down again.
the pull
and
of
I knew
gravity will make
immediately
the star
that
speed
that
up.
was the center of our Milky Way.
If it's
and that I
orbiting
was the
close
first
to a
person
massive black
to actually
hole,
see the star,
the
in
star
the core
should
of our
accelerate
galaxy.
to enormous speed
Located the heart of
and
the
then
Milky
whip
Way.
around the black hole like a
From our
slingshot.
perspective, an
Okay, so
inconspicuous
we have the
speck
black hole
near
here.
the constellation
The
Sagittarius.
more massive it is, the more polar
But as a
it is.
giant
The
spiraling
more
disk of
polar it
hundreds
is,
of billions
as it
of
gets
stars.
close to the black hole, the faster it goes.
100,000
And
light years
we are
from
measuring
end
the
to end.
speed of these stars. That's the key to getting the masses, measuring the
Our
speed of
sun,
those stars.
about halfway out from the center,
This is our
sits
road,
in the peaceful suburbs.
and that's the center of our galaxy. There's a large cluster of stars that are orbiting
But
the
at
center
the
of our
galaxy's
galaxy.
core,
And by measuring the
the
motion of
neighborhood
stars,
gets more
and in
exciting
particular their
and
orbits,
dangerous.
we
There's a
can
lot of
figure out
gas.
whether or not there's a
There's a lot
central
of
black
dust.
hole.
This is
That
absolutely
environment
the
in
most
there,
crowded place
it's a crowded
in our
party.
galaxy.
From Earth,
Ghez
we
set
can
out
see
to monitor the
1,000
partygoers,
stars with the naked eye.
to track
If you went to
every
the
movement
galactic
of the
center,
central
there would be
stars.
millions of stars filling the sky.
Basically, the way this experiment works is you take an image,
It's the big
you see where all the stars
It's
are,
where
and
the show
then
really goes
you
on
come
in the
back sometime
galaxy.
later and you take another
And
image.
so if you go
And
there,
you look to see if they've
you're
moved.
very
And
much
so
aware
the
of
second
being,
time we
a
took an
tiny
image, we
little mouse
knew
in
we
Times
were
Square and
golden.
somebody's
Those stars
liable
had
to
clearly
step on you.
moved.
This one moved to
For
here,
years,
this one moved to here,
scientists
this one moved to
suspected
here,
that a
and so
powerful
on.
force dominated
As
this
Ghez
galactic
continued to track
Times
the
Square.
stars, she found some
It had to come
making
from an
dramatic
unimaginably
hairpin turns.
massive object.
It made a huge jump to over here,
Had to be
going
a black
all
hole.
the way around. It's moving on order
An object
10
so
million
strange,
miles per hour.
it's
So
hard to
it's
describe.
just speeding away.
What's a black hole? It's
Other
a
astronomers
region of
clocked the
space.
stars with similar results.
It's a point of
Not only
infinite
were the
density.
stars
We
accelerating
don't
to
know how to wrap
phenomenal
our brains
speeds,
around that.
their orbits were perfectly smooth.
If you fall in, you never
Gez
come
knew
out.
that
not
they
the
had
point
to
of
be
no return,
circling
it's
a
the fear of
single
no
massive
return.
Now
object.
you throw in a hungry beast in the middle of it all.
Most
This
black
monstrous,
holes are thought to be about
mysterious
10
thing.
times
And if you
more
can imagine
massive
taking
than
a
our
bowling
sun.
ball,
But the object at the center of the Milky Way
That's not true.
was
have
roughly
something,
3
drop it
million
off the top
times
of
as
a
massive.
building, you're falling into the deepest well
For
you
Gez
can
and
possibly
Beckman,
imagine.
that could mean only one
Physicists
thing.
have just as hard a time as anybody else.
All other
understanding
physical
this sort of
explanations
thing.
of
It's a
what
black
was
hole.
at the very center were
There's no
gone.
other
The only thing left was
phrase
a
we
black
could
hole.
possibly use to describe it.
The current
Not
idea of
only
this
was this
bizarre
black hole
creature
supermassive,
comes from a radical
it was
view of
millions of
space,
miles wide.
time, and gravity.
astronomers around the world admitted
Welcome to the
the
universe,
evidence was
according
impressive.
to Albert Einstein.
I have to say, when I first saw
Einstein had this
Andrea's
crazy
video, I was
idea that
stunned
space
when I
and
saw that
time
star come
were
out of the left
curved.
side of the frame and
And
go
the
zipping
curvature of
around
space
and go shooting off into the other end of the
the
frame,
appearance
and
of
it
gravity.
moved around a point in space, and nothing was there.
We tend to think of space as rigid and
That
stable.
we could,
But
with
Einstein
our
proposed that
instruments,
space and time
effectively
are woven
travel to
together
the
in a
center of the
flexible
galaxy,
fabric.
26,000 light years away,
Massive
and
objects
collect
like
the
the
evidence
sun
for such
actually
an
bend and
incredible
warp the
object.
fabric of
It was
space-time,
really an amazing achievement.
creating troughs that smaller objects can fall into.
It seemed undeniable.
What actually happens
A
is
giant
matter
black hole
warps space-time.
at the
So the
center
very
of our
space,
Milky
the
Way.
three-dimensional space that we walk
But how
through,
could such a monstrosity come to
slightly.
be?
It warps in on me ever so slightly, but because we're not very massive, it's so minuscule
One idea
that
is
we
that
don't
black
sense
holes
it.
are born out of the death throes
If
of
an object
enormous
is
stars.
massive enough, like the Earth, it will warp space-time
Like a red
so we can
supergiant,
sense it,
a star
and fall
10
towards
times
it.
more massive than
That's
our own
gravity.
sun.
But what happens if an object is much, much
Deep
more
inside,
massive than the
temperatures
Earth or the
soar
sun?
above 1 billion degrees.
In theory, it could warp the fabric so much
Helium
it
and
would create
carbon
an actual
fuse into
hole
heavier
in
elements.
space-time.
Oxygen,
Once something
silicon,
fell in,
sulfur.
it couldn't escape. Not even light itself.
Eventually, the nuclear reaction creates
So
iron,
imagine a place
and the
where
core
the
stops
gravity is so
burning.
strong, turning on a flashlight. The light would go up and it
Then,
would never leave.
the star implodes
It would
under
curve and
its
come
own
back down,
immense
just the way a
gravity
tossed ball on
and
Earth.
goes
It's not traveling fast
supernova.
enough. It goes up, curves, and comes back down.
What's
Space
left
itself
is a heavy
falling
core of
inside
subatomic
the black
particles.
hole. It's rather like
A neutron
river
star.
falling over a waterfall.
Only about 10 miles across,
It's like that,
but
except
of
it's
incredible
space
density.
itself that's falling
In fact,
over the
it's so dense
cliff.
that a teaspoonful
There's
of
a place
neutron
where the
star
space
matter would
starts
weigh
moving faster
about
than
1
light.
billion tons.
If
So
the
the
neutron
light,
star
which
is heavy
trying to
enough,
get out,
3
it's rather
times
like a
more massive than our
kayak
sun or
trying to
more,
make their way
the implosion will
upstream
continue.
on a river that's going too fast. They get
Eventually, the
dragged down to the
gravitational
center of the
pressure will
black
be
hole.
so large that the neutrons themselves will be crushed, and there will
Gravity
be nothing
becomes
left
a
to stop the
riptide.
collapse.
The closer you get, the stronger the current. Eventually,
Many researchers
you reach
believe that the
event
Milky Way
horizon,
is littered with
the
small
point of
black
no
holes,
returns.
the dark, dense
Deep
remains
inside,
of dead
whatever
stars.
goes in is lost in a point of
There must
infinite
be
density.
millions and millions of black holes zipping around our
matter
galaxy
goes inside
as we
the
speak.
surface of the black
But we
hole,
don't see them in
shrinks
general because they're
down
dead.
to the
They're
very
corpses,
center where it
and
gets
there's
destroyed
nothing there
in
to
a
light
region
them
of
up.
infinite warp space and time, and it's gone.
They might be invisible,
And so,
but to a
it
visitor,
seems, are the
these
laws
small
of physics.
black holes, maybe 10 miles in diameter, would be
At the center
especially
of a black
deadly.
hole, all equations
One of the
break down.
scenarios that always
Even for physicists,
gets me thinking
what
is
happens deep inside a black hole
death by
is
black
a
hole.
mystery.
we're in want of a
Approaching
new
a
idea
black hole,
about how to
the
explain
gravity
what
is
matter
so
does
strong
at the center of a
and
black
space is so warped,
We're in need of a new
it
law of
distorts the
physics.
light all around it.
Einstein himself
If
concluded
it's a small black hole, then
holes
soon
were too strange
you'll
to
be
be
distorted
real.
too. By
Albert
tremendous
never really
tidal
liked
forces
the
of
idea
gravity.
of black holes.
The
He
tidal
thought
force
they were
is the
anathema.
difference
This was
between
something
gravity
that
at your
nature should
head
avoid.
and your feet.
The places
The gravity
where
at your feet,
space and time
close to the black
became
hole,
infinitely
it's strong,
twisted up.
The gravity at
He
your
thought,
head, and you feel
no,
it as something
nature
is
couldn't
tearing you
allow
apart.
Stretching you from head to toe. The tidal
holes are certainly
forces
odd
unrelentingly
beasts
getting
in the
stronger.
universe.
as they exceed the molecular forces that bind your flesh as you snap into two pieces, and those two pieces snap into
equations show
two
that they
pieces.
can exist
And
doesn't
ultimately,
require
pull your
that the real
atoms
universe
apart. You will
has
be,
them.
as we say, spaghettified.
But over the years,
And so you end
suspicions
up
rose.
moving through space-time like
Stars were found
toothpaste
behaving
through
strangely,
a tube.
orbiting invisible objects, moving faster than
And
expected.
if I pick a way to go, that's how I'd want to go.
Even though a black hole emits no
It's got to be
light,
better than just getting buried. I mean,
is
come on
completely invisible. We know
A
exactly what
supermassive
effect
black hole,
a black hole is
a
going to have
million
on
times
its environment,
wider,
on the
might at
stars in its
first
vicinity,
seem
on
more
the
inviting.
gas that wanders a little too
Since
close.
it has a larger
So,
event
will we ever
horizon,
see a black
the
hole?
pull of gravity is more
No.
spread out.
But that's not what's important
If you
here.
go
What's
to a
important here
supermassive
is
black hole, the
we can
tidal
see
forces are weak enough
its paw
that you
print.
can fall not only through the event horizon, but deep down into the interior of the black
Suspicious
hole.
that an enormous black hole was
So,
dominating the center of the
with a
Milky
good
Way.
spaceship, you
Eric
might be able
Becklin
to
was
cross
eager
the
to
event
find its
horizon
paw print.
into the black hole itself.
But even with infrared technology,
Now,
Becklin pointed
thanks
the
to a
most
computer
powerful
simulation
telescopes on
based on
Earth at its
Einstein's
target.
own equations,
all he saw was
we can
this,
see exactly what such a trip
just
would
a
look
blur.
like.
The biggest obstacle that we have
The
was
supermassive black hole
turbulence
is surrounded
in
by
our
swirling
own
light
Earth's
beams.
atmosphere
The
was blurring
superheated
the
gas
images.
rushes into orbit at high speed.
Even when the sky is clear, the gases in Earth's
Light
atmosphere
and matter are
always on the
suspended by
move,
centrifugal force,
distorting distant objects.
and then inevitably fall victim to the relentless pull of
To
gravity.
bring his view of the galactic center into focus, Becklin would need help.
At last you cross the event horizon,
So he appealed to Andrea
a point
Ghez,
where nothing can
an
escape.
expert in dealing with the atmospheric blur.
So
Biggest
let's imagine that we
very
fall
much
through
like
the
the
event
problem of
horizon.
looking for a penny
That's
at the bottom of
place
a river
where
that's
space
moving,
is
where the
moving
water's moving
faster
by
than
very
light.
quickly.
You fall
That
deeper down
motion of the
inside the
water
black hole.
distorts your image of the penny.
But don't expect the
Just
black
like the
hole
motion of
to
the
be
air
black.
in our atmosphere
Deep
distorts
within,
our images
there's
of
an inner
astronomical
horizon,
objects.
a logjam of trapped light and
Ghez
energy.
agreed to take on the quest, to search
At
for
a
signs of
certain
a black
moment, as
hole
we
at the
hit
center
the
of
inner
the Milky Way.
horizon, there's this infinitely
A decade
bright,
ago, you
blinding
couldn't look at
flash.
the center of our galaxy with high resolution, so you couldn't distinguish stars from
And
one
that's
another.
what the stuff that's
Ghez was
been
able to
waiting there
correct the
trying to
blurring
get
effects
out
of the
is
atmosphere
held there at the inner horizon.
with a revolutionary new technology called adaptive
Unfortunately,
optics.
you wouldn't have
So
long
this little
to enjoy the
animation
view.
shows you the benefit
It would
of adaptive
vaporize you.
optics. You see the stars
Roast you,
without adaptive
vaporize you,
optics, you turn the adaptive
marmalize you.
optics on, and all of a sudden you see
Almost
stars.
certainly,
And in
if you
particular,
fell
you
into a
see
real
stars
black
near the
hole,
center
you
of the
would simply,
galaxy.
unfortunately,
Without
die.
adaptive optics, you would only see one big blob.
Science
And those
fiction
stars are, in fact,
displays
the
a bit
most
more
important for us
optimism.
to track. We track all of them, but
Like
these
the
are the
1979
ones
movie,
that are the key to the
Black
problem.
Hole.
Maybe it doesn't hurt to take.
Space travelers
Thanks to the
do
new
indeed
technology,
fear this
the
massive
team could
object.
peer into the heart of the Milky Way.
Travel
with
where no
amazing
man has
precision.
dared to go.
Our view to the center of the galaxy
Into the black
is
hole?
absolutely superb.
Why,
And our
that's
ability to
crazy.
position stars
Cuckoo is a
at the
Swiss
center of the
clock.
galaxy is
But
like
even more
somebody
cuckoo,
in Los
the
Angeles
heroes actually
seeing somebody
survived
in
their
New
descent
York
into the beast,
be able to move their finger like this. Just
where
2
they're treated
centimeters. That's
to
the
a
precision
heavenly
with which
experience.
we can measure something that is 26,000 light years away from us.
Once the view was clear, Ghez could start the hunt. If there were a black hole
Popular
at the center of
culture
the
has
galaxy,
cast black holes
its paw
as
print
the
would be
freaks of
found
the
in the
universe.
rapid orbits of nearby stars.
Fingers crossed.
And the supermassive black hole at the center of our Milky Way, weighing in at 3 million times the mass of the Sun, seems especially monstrous.
Stars in the galactic
But is
center
it unique?
very, very accurately and with the highest precision possible.
To find out, astronomers are probing distant galaxies
When an object
to
like
see
a
if our
star
giant
approaches
black
another
hole is
more
one of a
massive
kind,
object,
or
the pull
nothing
of gravity
special.
will make the star speed up.
The Sloan Digital Sky Survey
If it's
is
orbiting
taking a
close to
census
a
of the
massive
big
black
galaxies
hole,
within a billion
the
light
star
years.
should accelerate to enormous speed and then whip around the black
For
hole
every
like
patch
a
of
slingshot.
sky, a steel plate is created.
So we have the black hole.
Each hole
here.
represents an
The
entire
more massive
galaxy
it is,
within our
the more
view.
pull there is. The more pull there is, as it gets close to the black hole, the
Fiber
faster
optic
it
sensors
goes.
are plugged in.
And we are measuring the speed of these stars.
Each measures
That's
the
key
distinctive
to
spectrum
getting
of
the
light
masses measuring the
emanating from
speed
a
of those
galaxy's
stars.
core. You can detect
This is our
signs of
roadmap.
hot gas swirling into a
And that's
black
the center of
hole.
our galaxy. There's a large cluster of stars
You can
that
see the
are
results.
orbiting the center of our galaxy.
Circled in red,
And by measuring
virtually
the motion of
every
stars,
major
and in
galaxy
particular,
bears the signature
their orbits,
of a supermassive
we
black
can
hole.
figure out whether or not there's a central black hole.
That was pretty amazing. Before that, we thought, yeah, maybe
Gez set
a
out to
large number
monitor
of
the
galaxies have black
partygoers,
holes in them, but
to track every
every
movement of
galaxy
the
has a
central
black hole.
stars.
That was something very interesting.
Basically,
closer
the way
we look
this
to the centers
experiment
of
works is you take an image,
the more we find these
you
black
see where
holes,
all
and
the
the
stars
inventory
are,
is rising
and then
high.
you come back sometime later and
any
you take another
idea for the
image.
formation of a galaxy
And
will
you
now
look to
have
see if
to
they've
include
moved. And so
some
the
explanation
second
for
time
how
we
you
took
get
an
a black
image,
hole
we
in the
knew we
center.
were golden. Those stars had clearly moved.
So how did every big galaxy in the
This
universe
one moved
end
to
up
here,
with a
this one
giant
moved
black
to here,
hole
this
in the
one moved
middle?
to here, and so on.
As
To
Gez
understand,
continued to track the
we
stars,
have to go back to
she
the very
found some
beginning.
making dramatic hairpin turns.
It made a huge
Big
jump
Bang.
to over here. So it all the way around. It's moving on order
You got the Big Bang
10
handing you
million
your
miles
birth
per hour.
ingredients, your
So
hydrogen, your
it's just
helium,
speeding away.
your traces of some other elements.
Other astronomers
So it's
clocked
kind of
the
like
stars
this,
with similar
this
results.
soup. You put it together and
Not only
stir.
were the stars accelerating to phenomenal speeds,
The main stirrer
their
for the
orbits
soup
were perfectly
is
smooth.
gravity. Drawing together
Gez knew
wisps of
that they
hot
had to be
primordial
circling a
gases.
single massive object.
Over time, the clouds of hydrogen gas cool
Most
down
black
and grow
holes
more
are
and
thought to
more
be about
dense
10 times
until
more
some
massive than our
coalesce
sun.
into the first stars.
The object at the center of the Milky Way was roughly
These
3
are
million
giants,
times as
hundreds
massive.
of times bigger than our sun.
For Gez and Beckman, that could mean only one thing.
They burn out quickly
All
and
other
dramatically.
physical explanations of what was at the very
the flash
center
of a supernova.
were gone. The only thing left was a black hole.
Not only was this black hole supermassive,
What's
it was
left at the
millions
core
of miles wide.
is a black hole.
Astronomers around
Perhaps
the
the black
world
hole
admitted
becomes the seed
the evidence was
from which
impressive.
the galaxy sprouts. The gravitational
I
seed
have to say, when I
that
first saw
is used
Andrea's
as an
video, I
attractive
was
force
stunned when I
to
saw that star
accumulate
come out of the,
the
left
rest of
side
what
of the
we would
frame
today then
and go
call
zipping
the greater
around
galaxy.
and go shooting off into the other end of the
Possibly
frame,
seeded
and
by
it
black
moved
holes,
around a
the
point in
infant
space,
galaxies dance
and
and orbit
nothing
one
was
another
there.
as gravity pulls them closer.
That we could, with our
So our
instruments,
Milky Way galaxy, as this
effectively
time-lapse
travel to the
simulation
center of the
shows,
galaxy
was not
26,000
born in one single
light
event.
years away and collect the
Instead,
evidence
it
for
was
such
built
an
over
incredible
billions of
object.
years
It was
from a swarm
really
of
an
smaller
amazing achievement.
galaxies smashing together, merging.
It seemed undeniable.
But if another galaxy comes
A
too
giant
close,
black hole.
they will each feel
at the
each other's
center of our
gravity.
Milky Way.
And in that collision,
But
what
how
started
could
out
such a
as a stately
monstrosity
ballet
come to be?
of stellar orbits moving around the center of their galaxy has now become this
One idea is that black
maelstrom.
holes are born out of the death
No other
throes
way
of
to say
enormous
it.
stars.
Galactic cannibalism, that's what they're doing.
Like
They're
a red
dining on their
supergiant,
neighbors, eating
a
entire
star 10
galaxies.
times more massive than our
Well, for
own
every
sun.
galaxy you eat, if that galaxy has a black hole in its center, it's going to
Deep
eat the black
inside,
hole.
temperatures soar above a
The
billion
black hole
degrees.
will work its way down to the center of the large galaxy,
Helium and carbon
making
fuse into heavier
the center of the
elements.
galaxy bigger as well as the galaxy itself.
Silicon, sulfur.
It's just that simple. The big galaxies get bigger.
Eventually,
The
the
little
nuclear
ones get
reaction creates iron, and the core stops burning.
Galactic cannibalism is how galaxies
Then,
grow.
The
And
star
with them,
implodes
the black
under
holes
its
of their
own
centers
immense
merge
gravity
and grow bigger.
and goes supernova.
But what does the presence of such a
What's
monster
left
mean
is a
for
heavy
the life
core
of a
of
galaxy?
subatomic particles. A neutron star. Only about 10 miles across, but of incredible density.
Brian McNamara believes he's found the
It's so
answer.
dense that a
isn't
teaspoonful of
pretty.
neutron star matter would weigh about
That's
a
it
billion
right there.
tons.
If the neutron star is heavy enough, 3 times
it?
more massive than
Okay,
our
so
sun or more,
McNamara studies
The
the life
implosion will
cycles of the
continue.
universe's biggest structures,
Eventually,
galaxy
the gravitational
clusters.
pressure will be
There
so
it is.
large that
That's
the
the
neutrons
galaxy.
themselves
So
will
that's
be
what we've been
crushed,
looking for.
and there'll
This
be
is
nothing left to
the
stop
giant
collapse.
central galaxy in a galaxy cluster, and each one of these little dots
Many
here
researchers
on the
believe
screen
that the Milky Way
is a
is
giant
littered with
galaxy
small
as big as our
black
Milky
holes.
Way,
dark,
maybe even a
dense
little bit
remains of
bigger,
dead
and they're all
stars.
bound together by their own neutral
There must
gravity.
be millions and
So they're
millions
all
of black holes
buzzing around,
zipping
this
around our
giant
galaxy
like
as we
bees buzzing
speak.
around a hive.
But we don't see them in general because they're dead. They're corpses, and there's nothing there to light them up. 180, 180.
McNamara
They
probes
might
his
be
galaxies
invisible
with multiple tools.
to a visitor. These small black holes, maybe
Optical
10 miles in
telescopes,
diameter,
radio
would be
receivers,
especially deadly.
even X-rays.
One of the scenarios that
there we
always gets me thinking
Check
is
that out.
X-ray
death by
images
black
reveal
hole.
a vast cloud of hot gas through the whole
Approaching a
cluster
black hole,
across hundreds
the
of
gravity is
thousands
so
of light
strong
years.
in in space is so
There's an
warped,
atmosphere of
it
gas
distorts the light all around
that
you.
pervades the entire galaxy cluster.
it's a small
and it's an
black hole,
atmosphere
then
like our
soon
atmosphere,
you'll
except
be
that it's
distorted
far less
too.
dense and it's
By tremendous tidal forces of
much
gravity.
hotter.
But when McNamara looked at X-rays of the gas around certain clusters, he saw that vast clumps of it appeared to be missing.
Closer to the black hole, it's a little bit stronger.
I was blown away. I'll never forget the moment we got the observations, and lo and behold,
Stretching you
these
from head
two
to toe.
giant
The
cavities
tidal
showed up
forces
in the X-ray
unrelentingly
emission.
getting stronger.
The size of the
as they
cavities
exceed
was
the
astounding.
molecular forces that
That's
bind your flesh.
200,000,
As you snap
600,000
into
light
two
years.
pieces, and those two pieces snap
so
into
between
another
that
two pieces.
cavity here
And ultimately,
and this
you'll
cavity
pull
here,
atoms apart.
you
You'll
can
be, as we say,
stuff 600 Milky
spaghettified.
Ways in there.
And so
it's
you
just
end up
astonishing.
moving through space-time
The
like
energy involved
toothpaste
is
through
huge.
a tube.
Something powerful had pushed the gas
And
away
if I pick a way to
across
go, that's
vast
how I wanna
regions
go.
of the universe.
It's got to be better than just getting buried.
McNamara traced the
Come on.
power source to the center of a giant galaxy,
A supermassive black hole,
a
a
supermassive
million
black
times
hole.
wider, might at first
So we
seem
can
more
see the
inviting.
beam coming out of the
Since it
black
has a
hole
larger
and
event
ending
horizon,
up in these big
the pull
cavities.
of gravity is more spread out.
But how can a black hole,
If you go to a
a
supermassive
creature
black
famous
hole,
for devouring
the tidal
everything within
forces
its
are
grasp,
weak enough
spew
that you can
energy
fall
across
not
the
only
universe?
through the event horizon, but deep down into the
The
interior
answer
of
lies in the
black
way
hole.
matter falls toward the black hole.
So, with
It
a good
turns out
spaceship,
nothing
you might
goes
be able
straight
to
in.
cross the event horizon into the black hole itself.
As matter falls in, what we know now
Now,
is that it
thanks to a
spirals
computer
around
simulation
in a
based on
disk.
Einstein's own
Okay,
equations,
very much the way when water
can see
goes down
exactly
the
what
drain.
such a trip
It doesn't
would
just
look
go straight down the drain.
Just as water spirals down a drain in a
the
whirlpool,
supermassive black hole is surrounded
matter
by
and light
swirling
spiral
light
at high speed into a black
as
hole.
superheated gas rushes into orbit at high speed.
And the speeds that matter can achieve
Light and
around that
matter are
black hole
suspended by
approach the speed of
centrifugal
light.
force.
And when matter travels at that
And
speed,
then
it gets a
inevitably fall
tremendous
victim
amount
to
of
the
energy.
relentless pull of
Matter
gravity.
falling into a black hole is a lot
At last you cross
of stuff trying to
the
get
event
into a very
horizon.
small place. And so it's
Point
like
where
trying to
nothing
fill a
can
dog
escape.
dish with a fire hose. Most isn't going to get in.
So let's imagine
The black
that we
hole
fall
chokes on
through
the
event
influx.
horizon. That's the place where space
The
is
high-speed
moving
whirlpool of
faster
matter
than light.
produces a
So
powerful
deeper down
magnetic
inside
field,
the black hole,
coiling around the black hole and
But
shooting
don't
the
expect
energy
the black
outward.
hole to be black.
These enormous
Deep
jets of
within,
energy,
there's an
hundreds
inner
of millions
horizon,
of times the power
a
of the sun,
logjam of trapped
can blast
light and
right out of
energy.
the galaxy.
at a certain moment, as we hit the inner
There's no
horizon,
question
there's this
that
infinitely
the black
bright,
holes at the centers of
blinding
galaxies
flash.
have a profound influence on their surrounding. They send out these
that's what the
huge
stuff-
jets moving at almost the speed of light. And those jets can send shock waves into the surrounding medium and change their surroundings completely. They have a dramatic influence.
Not only can they blast away huge quantities of gas, but they may even sterilize the galaxy, so new stars can't form.
The supermassive black holes at the center may be responsible for limiting the size of galaxies. In principle, galaxies can grow to very, very large sizes, and what we see in the universe is that they don't. And we think that the supermassive black holes at the center may be the culprit. They may be responsible for preventing runaway growth of galaxies.
We usually think of black holes as God's dumpster, but they really are actors on the galactic stage.
If supermassive black holes can wreak so much havoc, what's to stop our own monster of the Milky Way from wiping us all out? It all depends on the monster's diet.
Most of the time, a black hole isn't eating. It fasts more than it feasts. But when a black hole feasts, it can have a tremendous effect on the surrounding galaxy.
The more black holes chow down, the more matter and energy will blast outwards.
One of the key differences between galaxies with supermassive black holes is whether or not their black holes are lit up, because they're basically binging on a lot of material in its surroundings.